All right, welcome back to statics. I'm going to be doing kind of a continuation of my last video. I'm just doing another problem on components, separating a force into its components. So you see in this one, I have a little mini version of it up here. We are trying to find the components of force 2, this one here. So I'm just going to write, I'm not going to solve this one graphically, I'm just going to solve it analytically, but I'm going to apply the same approach. So I'm going to just draw our V component here. And then I'm still going to use the protractor to find the other component because it's just easy that way. 75 degrees, which is right here. All right, one thing that I should note that's different from my last one is that instead of having, obviously the lines are different with different angles, but instead of having V up here and U right here, V is now here and U is down here. So we probably are gonna have some sort of negative number for one of our components. Let me just write the angles in here. So we have 75 degrees here. And then I can throw away F1 because we're only focused on F2. And then it's a 30-degree angle from that. Ten, 20, 30. All right, and because we're solving it analytically, I don't need to worry about the actual distance or length of F2 here. All we need to know is that F2 is equal to 40 newtons. That's given. Okay. I should have drew that in red. I did not. I'll write the angle in red though. The angle here is 38 degrees. All right. So first, I'm gonna find the parallel lines here. So we see that the component of U can be written here. All right, I'm actually going to extend that a little bit further. All right, so this line is F2U. It's F2U and not F1U because we are focused on the force F2. If we were working with the force F1, it'd be F1U, but this is F2U. And it's U because it's the parallel line of the vector line U here. So because it's parallel to U, it is the force 2 in the U direction. It's the component of force 2 in the U direction. So now I'm going to find in the V direction. Okay, here. What am I doing? Whoops. Yes. There we go. This side is better. And then I have to move it down here. It's a bit hard. I'm working with limited space. That's good enough. Now, I'm just doing these with rulers and angles and protractors and everything. You don't need them. I just like everything being neat for you guys. You can absolutely just eyeball it as long as you get parallel line to V and a parallel line to U instead of just going straight to the axis line. So because this is parallel to V, we call this F2V because it's based off of the force 2, and it is in the v direction. So it's the component of v, it's a component of force 2 in the v direction. So what we're going to do is we're first going to find the angles. So we have 30 degrees here, and because F2U and U are parallel lines and it's intersected by this force, this angle here is the same as this angle right here, which means that this is 30 degrees. We can apply that same principle to here. V and F2V right here are both parallel lines. Oh, sorry, F2U, U, both parallel lines intersected by V, which gives us that this angle is the same as this angle. So we have this angle equals 75 degrees. Now, in order to find this third one, we just have to do 180 minus 75 minus 30, which gives us 75 degrees. So this angle right here is 75 degrees as well. Then we can use that same principle that we were talking about right here. F2U and U intersected by force 2. This 75 is equal to this part. So this is 75 degrees, 75, 30. We notice that we have a 75 and a 30 here, which means that this last angle is also 75 degrees. We can double check that this angle is 75 degrees because we can use that same principle that we were just talking about to means that this angle right here is, I'm going to write this in red. This angle right here is also 75 degrees. And another angle property, this angle is going to be equal to this angle, which we see is correct here. All right. Now, what we can do is we can actually solve for the equation. So we need to find the components F2U and F2V. Remember, law of sines. If we have angle A, B, and C, side A, B, and C, then side A divided by the sine of angle A is equal to side B divided by sine of angle B, which is equal to side C divided by sine of angle C. All right, make sure you guys can see that. So what we're going to do here is we're going to say that F2U, the opposite angle of F2U is right here, 75 degrees. So F2U over sine of 75 is equal to the force 2, which is 40 newtons. So I'm just going to write 40 here, over the opposite angle of side F2 is right here, 75 degrees. Or if we want to use the other triangle, 75 degrees. Both of these triangles, again, both of these triangles are the same. 75, 75, 75, 75, 30, 30, because the area of a triangle is 1/2 the area of a parallelogram or a rectangle, which is exactly what we have here. So both of these triangles are the exact same. You only actually need one of them to do the answer to the question. I just give you guys both for extra practice. So we have 40 over sine 75. And then this equals, if we were trying to find F2V over the opposite of F2V is sine 30. Or it's 30 degrees, but it's sine 30 in law of sines. Law of sines. Okay, now we pick and choose. If we want F2, then F2U, we need to multiply sine 75 to the other side to get rid of it here. So we get F2U, this is just simple algebraic expressions. F2U equals 40 over sine 75 times sine 75. Now, these sine 75s are going to cancel, and you're just going to be left with 40 newtons. And then, if we want F2V, we focus on here. We need to multiply sine 30 to this side in order to isolate F2V. So F2V is going to be equal to 40 over sine 75 times sine of 30. So F2V equals 40 sine 30 over sine 75. And if you put that into a calculator to calculate it, you're going to end up with 20.71 newtons. So that's the answer for, actually, no, it's not. If we were asked for the magnitude, this would be your answer. Because magnitude, remember, magnitude is always an absolute value. So if the question is asking you for the magnitude of each component, the magnitude of F2U would be 40 newtons, and the magnitude of F2V would be 20.71 newtons. However, I'm just asking for the components, so we have to include positive and negative. So here, V going up this way is in the positive direction. V going down this way is in the negative direction. So for F2V, in order to get to our position here, remember that this component, F2V, is equal to this component because these are both F2V. In order to get to our F2 angle, we have to go left. This component is going to the left because in order to reach this position, if we imagine this as the y-axis and we imagine that this is offset like a couple centimeters from the y-axis, in order to get to this point, we'd have to go in the negative direction, or in this case, I guess it'd be better if this was x. We'd have to go to the negative direction in order to reach that point. So that means that this position here, F2V, is going in the negative v direction. So this component, F2V, is actually not 20.71 newtons. It would be negative 20.71 newtons because this is in the negative direction, negative F2V. I'm just going to draw an arrow here to apply that. And then F2U in the positive direction would be going down, and F2U in the negative direction would be going up. So in order to get to this point from F2U, you see we are going in the down direction, which means that this is positive. So 40 newtons positive is correct for F2U. So the answer to this question, in their components, it would be F2U equals 40 newtons, F2V equals negative 20.71 newtons. And if you wanted the magnitude of the F2U component would just be 40 newtons, and the magnitude of the F2V component would just be 20.71 newtons because it's the absolute value. The magnitude is always positive. So that's the solution for this one. And if you needed to find F1, you would just do the same exact practice just with F1 this way. Remember, you don't need protractors or anything for this. You can absolutely do it without. I just use it so that everything's nice and neat for you guys to see. All right, good luck with statics.